Good day. So in this video, we are going to discuss the analytical geometry. But before we do that, I just want to take this moment to appreciate all those who have subscribed to my channel. And if you are new to this channel, please go ahead and hit that subscribe button and also share these videos with colleagues and friends. Now, getting back to today's business. So I will try to present to you here analytical geometry that you do in grade 11 and 12 in under 30 minutes. And analytical geometry is quite easy. So this is one of the sections that you need to score all the full marks. So I will also do the equations of circles. So yeah, without wasting time, let's get into it. Now, if you are given, let's suppose you're given the line AB, which has got the coordinates x1, y1, and also the coordinates of b, x2, y2. The gradient of the line AB, which is MAB, can be calculated using the formula increase in y or change in y, which is y2 minus y1 over x2 minus x1. And this is the formula that you use to calculate the gradient. And once you have the gradient also, you can actually calculate the angle of inclination. So we call this the angle of inclination. It is an inclination to the horizontal axis. So if you have got your vertical axis y and also the horizontal axis x, and you have got a line that passes through like that. So the angle of inclination, it is this angle here. So this is the angle theta. So it is always to the right of the line. So in this case, the angle of inclination in here will be that. So that will be your theta. So to calculate the angle theta, you will say that m is equal to, so the gradient m is always equal to tan theta. Tan theta. So m, so once you have got your gradient, you can say tan inverse of m, then that gives you the inclination angle. So you get your inclination angle with the inverse of m. Also, if you only have got the theta angle, you can also determine the gradient. So m will be equal to tan theta. So yeah, that is what you do. So let's suppose here the theta is 15 degrees. Then the gradient of that line will just be equal to tan 15 degrees. And let's suppose then the gradient was 2. Then the angle of inclination will just be equal to tan inverse 2. And that is how you calculate the angle of inclination. Now, then the other thing that you need to know is the parallel, perpendicular, and collinear lines. So the parallel lines, you have to remember also that the parallel lines, so this is just revision. Remember the parallel lines, you've got the same gradient. So sometimes they give you a shape and they will ask you, maybe they give you the coordinates for this line here and they tell you that it's parallel to that line. So always look out for these signs. So if it is parallel, you can actually determine the gradient of this line and that will be equal to the gradient of this line. So M1 in this case will be equal to M2. So the gradients will be the same for the parallel lines. So remember, parallel lines, you have got equal gradients. Look out for the signs of these parallel lines. Now, the next thing that we need to talk about is perpendicular lines. Remember perpendicular lines. So these are lines at 90 degrees. So if you've got two lines at 90 degrees with the gradient M1 and M2, then you have to remember that the product of these gradients, M1 times the gradient of the line M2 will be equal to -1. So let's suppose the gradient of this line is a 4. Then automatically the gradient of M2 will be an inverse of that times a negative. So that will just be a quarter, then you put a negative. So the gradient of M2 in this case will be equal to -1/4. Then the other thing that you need to remember is about collinear lines, the collinear points. So the points that are in the same line. So if you have got a point here, let's suppose point A and point B and also point C. So if you are told that these points are on the same line, you can actually, and you're given the coordinates here, let's suppose it's a 2 and a 4, and you're also given the coordinates here, let's say a 6 and a 3, and you're given one coordinate here, you can be able to calculate the other coordinate y. Because remember, you can determine the gradient of AC, then that gradient will be the same as the gradient of AB because these points are collinear. Hence the gradient here, or between these 2 points will be equal. Now, just to give you a summary of what we've been saying, remember we said that now if you've got 2 points, the gradient m is equal to y2 minus y1 divided by x2 minus x1. And remember what we said, that the parallel lines, you've got same gradient, so m1 is equal to m2. So in this case, that will be m1 and m2. And also remember what we said, the perpendicular lines. So if lines are perpendicular, the product of their gradients m1 times m2 will be always equal to -1. So this is just a summary. And also remember what we said, the gradient of a line, if you're given the angle of inclination, is also equal to tan theta. And also to calculate the angle theta, you can say now the inverse of tan gradient will give you also the angle theta. Now, let's look at another example whereby we work with an example from an examination. Now, let's look at this given example. We are given the shape A, F, C, D, and E. So you can see this is like a triangle, and also the line BC produced to E. So we are asked here to calculate the gradient of BE. So calculate the gradient of BE. So that is the point B here, and also E. So you can see now we don't have the coordinates B, but since C is part of the line BE, so you can use the coordinates CE to calculate the gradient. So the gradient, remember, M is equal to y2 minus y1, and that will be equal to, so in this case, I'll take this as my y2 and this one as my y1. So that will be equal to 0 minus 2 bracket divided by a 12 minus 4. And this gives us a gradient of a quarter. So the gradient of BE is a quarter. Now, moving on to the second question, we are also asked to calculate the gradient of AB. So if you look at the line AB, so this is the line AB here, we do not have enough coordinates. We only have coordinates of A, and we do not have the B coordinate. But we are given the angle of inclination, which is 81.87 degrees. And remember, we say that if we have got an angle of inclination, the gradient can be calculated of a line using M is equal to tan theta. So in this case, M is equal to tan bracket 81.87, and that will give you 7. So the gradient of the line will be equal to 7. Now, moving on to part 3. In part 3, we are asked to determine the equation of BE, so the line BE in the form y is equal to mx plus c. So what we just need here is the gradient, and we calculate the value of c. And we already have the gradient of BE. Remember, we determined it was a quarter. So then for part 3, y will be equal to a quarter x, then plus a constant c. Then to get our value of c, we can just use any point on the line BE to get the value of c. In this case, we just use point E, and we let here now, you can see your y is 0, so 0 will be equal to a quarter multiplied by 12, then plus a constant c. And you can see that your c in this case will be equal to, so that will be -3. Then the equation of the line BE will be equal to y is equal to a quarter x minus a 3. That will be the equation of the line. That will be a quarter x minus a 3. Now, moving on to part 4, we are asked to determine the coordinates of point B. So that is the point B that has got the coordinates k, k. So you can see that the point B is collinear with point C and E. So because it's kk, you know that it will be the same value for the x and the y coordinate because they are the same. So since we know the gradient of the line CE, and we determined the gradient of BE, so the gradient of CE will just be the same as the gradient of BE. So in this case, now since we know the gradient of the line B, so the line B, so MBE, we calculated that was a quarter. We can also now calculate the gradient of BC using B, because B is in collinear. So the gradient at BC will also be equal to the same at the gradient at CE. So in this case, we can say MCE, not CE, CB, will be equal to, remember it's y2 again minus y1 divided by x2 minus x1. So that will be equal to, in this case, that will be a 4 minus k divided by, not a 4, sorry, that should be a y first, so the y value. So the y value is negative 2 minus k, then divided by 4 minus k. And this should give us a gradient of a quarter because it's on the same line. So this should be equal to a quarter. So to solve that, we just say 4 minus k will be equal to, we just cross multiply, then that will be negative 8 minus 4k. And that will give us, so in this case, that will be 3k is equal to negative 12. Then k is equal to negative 4. So k is negative 4 and also negative 4. So x, the coordinates there will just be negative 4 and negative 4. That will be the coordinates of the point B. Now, moving on to point number 5, we are asked to calculate the size of the angle A. The size of the angle A, that angle there. So here we are going to use this triangle here to determine the size A, because we know already the angle F, and we can calculate this angle using the inclination. So we need to find the gradient of M. So that will be the gradient of AC. So in this case, the gradient of AC will be equal to, so that will be y2 again minus y1 divided by x2 minus x1. And that will give us y2, it's a 10. So that will be 10 minus 2 divided by negative 2 minus 4. And this will give us a negative 2. Now, since we have the gradient, we can calculate the angle. Remember, to calculate the angle, theta is equal to tan inverse M. So if we have got the gradient, we can say tan inverse M. So theta will be equal to tan inverse negative 2. And in this case, our theta will be equal to negative 63 degrees. So the reason why it's a negative 63 degrees, because this angle here is an obtuse angle. So you are literally calculating the other angle. So this is the negative 63, which is just equal to 63 degrees. So now we know that that angle is 63 degrees. We can just say now the value of A will be equal. So the angle A plus B, not B, angle A plus the D, angle A plus D plus F will be equal to 180 degrees. And we can easily find the angle D now. So because D will be equal to 180 minus angle F, and we have got the angle F, which is 81.87 degrees, then minus the angle A, which minus the angle D, which is the one that we have calculated, that was 63 degrees. And if you calculate that, you see that D will be equal to 35 degrees. And that is how you do this question. Let me know if you have got any questions or point of clarifications. Now, moving on to the midpoint. So the other thing that you'll be asked to determine and that you are required to know in analytical geometry is to determine the midpoint of a line. And this is quite easy. So if you have got the line, again, AB with the coordinates x1, y1, and x2 and y2, and where M is the midpoint, so which means that AM will be equal to BM. Then the coordinates of the midpoint, which is capital letter A, so the midpoint AB can be calculated using the formula x1 plus x2. So that will be the x coordinate of this and that, then divided by 2, and the y coordinate will just be equal to y2 plus y1. It really doesn't matter what you start with because you're adding. Then also this divided by 2. And this is how you determine the coordinates of the midpoint. Now let's look at an example. Now, in this question, we are given again the diagram A, B, C, D, E, and F. And we are asked to calculate the coordinates of D, and that is the midpoint of AC. So if you remember very well, the midpoint of a line, so in this case, it will be midpoint of AC, will be equal to, remember the formula, x1 plus x2, then divided by 2, and also the y coordinate will be y1 plus y2, then divided by 2. So in this case, that will be equal to, so that the x coordinate, the x1 will be negative 2 plus a 4, then divided by a 2, and also it will be a 10 plus negative 2, also divided by 2. And this gives us negative 2 plus 4, that will be a 2, then that gives us a 1. And here that will be 10 minus 2, that will be 8, then divided by, that will be a 4. Therefore, the point D is equal to 1, 4. So D4 is 1, 4. And this is quite easy. And this is how you determine the coordinates of D, which is the midpoint of AC. Now, in the next question, we are asked to determine the coordinates of J such that ACEJ is a parallelogram. So these questions, they like them a lot. Let me just make some space here. So they like them a lot. Sometimes they say that the shape will be a rhombus, the shape will be a rectangle, the shape will be, or sometimes a square. So what I'm going to show you here is exactly what you do with all those different shapes. So they are saying determine the coordinates of J such that ACE. So this is our A, C, E, J. So which means there is like a point J somewhere there. So this to be a parallelogram. So we need to determine that coordinates of the point J here. Now to do that, you need to know that the diagonals of a parallelogram, its diagonals, they bisect each other. So they bisect, which means they divide into 2. So this one will divide into equal parts, and also this one will divide into equal parts. Remember, in a parallelogram, there is a longer diagonal and a shorter diagonal, but they bisect each other into 2 equal parts. So the first thing that we need to determine is that midpoint there. So to do that, we use the one that we have got all the coordinates. In this case, that will be A and E. So to determine the midpoint of, so let's say this point, it's K. So to determine the point of K, the midpoint, which is the center where the diagonals of the parallelogram bisect each other, will be equal to, remember the formula, x1 plus x2 divided by 2, and also y1 plus y2 then divided by 2. And in this case, that will be equal to, so that will be, an x is negative 2 plus 12, then divide by 2, and also here 10 plus 0 divided by 2. And that gives us here, that will be a 5, and also there, that will be a 5. So now we know the midpoint, that is 5, 5. So this is also a midpoint of the line CJ. The midpoint of AE is the same as the midpoint of CJ, because remember, we said the diagonals of a parallelogram, they bisect each other. So with that in mind, we can go ahead and find the midpoint K using the coordinates of J. And let's say the coordinates of J here, it's X and Y. So to calculate the midpoint, which is CJ, that will be equal to, in this case, that will be a 4 plus X divided by 2. And also this midpoint, because it's the X value, so this should be equal to 5, because we know already the midpoint value. So this can be simplified further to be 4 plus X is equal to 10, and X is equal to a 6. And we can do the same thing for the Y coordinate, and we calculate the midpoint. That will be, for Y, it's minus 2, the coordinate of here of C, plus Y. So minus 2 plus Y, then divided by 2, should also give us the Y coordinate of the midpoint, which is also 5. And this can be simplified further to be negative 2 plus Y is equal to 10, and Y will equal to 12. So now we have got the coordinates of J. So J will be 6 and 12. And this is how you determine the fourth coordinates. To make it a parallelogram, you always determine the midpoint first of the given coordinates, then you use the other 2 points to determine the value of the coordinate that you're being asked for. And this is how you do it. Now, moving on to the distance formula. Now, the other thing that you'll be required to know in analytical geometry is to determine the distance between points. So once again, you are given the point A and point B, forming the line AB with the coordinates x1, y1, and also x2 and y2. To determine the distance, that is the length of AB, will be equal to, use the formula, that will be the square root of, in a bracket, x2 minus x1 bracket squared plus bracket y2 minus y1 bracket squared. And I'm sure you are quite familiar with this formula, and it's quite easy. So now let's jump into an example and show how to determine the length of a line. So in this example, once again, we are given the shape A, B, C, D, E, and F. And we are asked to calculate the length of AC. So remember, this is the length. We have got 2 points, A, -2 and 10, and C, 4 and -2. So the length of the line AC will be equal to, remember we said, the square root of bracket x2 minus x1 bracket squared, then plus bracket y2 minus y1 bracket squared. And in this case, that will be AC will be equal to the square root of 4 bracket minus 2 bracket squared, then plus in a bracket minus 2 minus 10 bracket squared. And if you simplify this in your calculator, you find that AC will be equal to the square root of here, that will be 36 plus 144 here. And this will simplify further to be the square root of 180. And this is equal to 13.42 units. And this is how you determine the length of a line. Now, moving on to the circles. Now, circles are one of also the easy things to do. So if you are given a circle, so this is the circle with the radius r and the center AB, the general equation of a circle can be expressed using this equation, x minus a bracket squared plus bracket y minus b bracket squared is equal to r squared. Where your a is, so the a here, you can see the x coordinate of the center, and your b is the y coordinate of the center, and your r will be the radius squared. So you need to determine the radius, then you square it, and you just plug in the coordinates of the center. And there you go, you have got the equation of the circle. And this is how you determine the equation of the circle, and it's quite easy. Now, let's look at an example. Now, in this example, we are given the line AB with the coordinates A, -2 and 10, and B, 4 and -2. And we are asked to determine the equation of a circle with AB as a diameter. So AB is a diameter. So if you want to think about it, that would be like a circle going around like that. So that forming AB to be the diameter, which means you can calculate the point, the midpoint of AB, and that will be the center. So we are asked to determine the equation. So we just need, remember, for the equation of a circle, the equation of the circle is in the form x minus a bracket squared plus bracket y minus b bracket squared is equal to r squared. So we just need the a and the b, so which is the center in this case. So the midpoint of AB, because it's the center, will be equal to, we calculate that using the midpoint formula, x1 plus x2 divided by 2, then bracket y1 plus y2, then also divided by 2. And that will be equal to, in this case, that will be a -2 plus 4, then divide by 2. And for the y coordinate, that will be 10 minus 2 divided by 2. And this gives us a midpoint of 1 and 4. So now we have got our center, which is also the value of A and B. So what we just now need to do is to determine the radius. So to determine the radius, because now we have got 1, 4, so we can determine the radius with the point M and A. And to do that, we just use the distance formula. So the distance MA, which is also the radius, I'll just call it the radius in this case, which is also the radius. So the radius will be equal to the square root of, so in this case, that will be a 1 minus, so that will be plus 2 bracket squared. So we're using this coordinate and this coordinate, and plus in a bracket, that will be a 4 for the y coordinate minus 10 bracket, and that will be equal to the square root of, here it will be a 9 plus here 36, and that is equal to the square root of 45. And remember what we need an r squared, of which here we determined r. So r squared will just be equal to, we square the 45, the square root of 45, and that will be just equal to 45. Now we have got our r squared and we've got a and b. Now let's go ahead and plug this into this equation, and then we come out with the equation of a circle. Now, since we have that a and b and also our r squared, and remember the equation of the circle is equal to x minus a bracket squared plus bracket y minus b bracket squared is equal to r squared. Then in this case, the a is, well, that will be 1. So x minus 1 bracket squared plus bracket y minus the b is a 4 bracket squared is equal to r squared, which is 45. And there you go. That is the equation of the circle of this question. Let me know if you've got any questions or point of clarification. Now, the equation of the circle that I've shown you in the previous section was x minus a bracket squared plus bracket y minus b bracket squared is equal to r squared. So if you expand this equation, it can also be written in this format. So it will be written in this format. So when you are given the equation in this format and they are asked to determine the center and the radius of the circle in this format, so what you simply do, you just say the radius, the center of the circle will be equal to negative half multiplied by the coefficient. So negative half multiplied by the coefficient of x. So in this case, if you look at this equation, the coefficient of x is a. So that will be just equal to negative half times a. Then also for the y coordinate is the same thing. That will be negative half multiplied by the coefficient of y. So coefficient of y. So in this case, the coefficient of y will be negative half times the coefficient of y is a b. So then the coordinates of the center will just equal to negative half a and negative half b. And that is how you determine the center and the center, which is the x coordinate of the center and the y coordinate of the center. Now, to determine the radius. So if you are asked to determine the radius, let me just make some space. So remember, the center is minus half coefficient of x and minus half coefficient of y. So if it's the equation, if it is in this format and you are asked to determine the radius, so you should always make sure that the equation is always equal to 0. So if there is any value, take it to this side, then it has to be equal to 0. So to determine the radius, so the radius will be equal to, so whatever value we have gotten for the, remember we determined the coordinates of the center, and the coordinates of center will be a and b. So then you just square the coordinates, which is a squared plus b squared. I'll explain this when we're doing an example. Then minus a c. So this is your x coordinate of the center and the y coordinate of the center. Then minus c, which is this constant here. Then the square root of that gives you already the radius of the line. Now let's look at an example. Now in this question, you are asked to determine the center and the radius of the circle with the equation x squared minus plus y squared minus 2x minus 8y minus 28. So if you remember very well, we said that the coordinates of the center, so the center in this case will be equal to, remember we said negative half multiplied by the coefficient of x, and in this case coefficient of x is negative 2, then and also negative half multiplied by the coefficient of y, and in this case coefficient of y is negative 8. Not x squared or y squared, but x and y. And this can simplify further to be 1 and a 4. And there you go. You have got your coordinates of the center, which is also a and b, if you remember very well. Now, to determine the radius, remember we said for the radius, so the radius will be equal to the square root of the x coordinate of the center squared plus the y coordinate of the center squared, which is your a and b that you have gotten here. Then also from the formula, we said that will be minus a c at the constant. And remember, we said this has to be equal to 0. So the constant has to be always this sign. So this will be simplified further to be the square root of a squared. It's 1 squared plus 4 squared. Then minus 28, that will be plus 28. And then you realize that the radius will be equal to the square root of 45. And this is how you determine the center and the radius of the circle. Now moving on to the tangent of the circle. Now, the other thing that you'll be required to determine is the equation of a tangent or a normal to the circle. So in this case, we have got an example that we're going to work with, and we have got the tangent DE at the point of intersection of B, 4 and negative 2, and the center 1, 4, and also point A, which is negative 2 and 10. And we are asked to determine the equation of the tangent DE to the circle at point B. So remember, the equation of a tangent is just in the format y is equal to mx plus AC. So we just need to determine our m and our c. Then we have the equation of a tangent. But if you look on the point DE, we do not have sufficient points yet to determine the gradient of that line. So what we will do, remember, we can construct here our radius. And if you remember from circle geometry that at a point of intersection of a radius and a tangent, there forms a 90 degree. So we can actually determine the gradient of this line, and that is the normal, by the way, and this is the tangent. So we can actually determine the gradient of the normal, then we can inverse it and multiply by a negative, then we can get a gradient of a tangent. And because you remember that the gradient of perpendicular lines m1 times m2 will always be equal to negative 1. So in this case, we can determine the gradient CB, small letter, which will be equal to y2 minus y1 divided by x2 minus x1. And in this case, that will be negative 2 minus 4 divided by 4 minus 1, and that will give you negative 2. So the gradient of this normal is negative 2. But we don't want the gradient of the normal. We want the gradient of a tangent. So the gradient of a tangent will be an inverse of that. So that will be a half. So the gradient of the line MDE will be equal to a half. So once we have that gradient, now we can punch that y is equal to mx, that will be a half, x, then plus a c. And we can substitute these coordinates. So for y, we put negative 2. Then for x, we'll put in a 4. So then plus a c. And that will be simplified further to be negative 2. Then that will be here a 2. Then that will become the side negative 2, that will be negative 4. So our c value is equal to negative 4. And then therefore the equation of the tangent will be y is equal to a half x minus 4. And there you go, you have got the equation of the tangent. And this marks the end of this chapter on analytical geometry. Let me know if you have got any questions or point of clarifications. It's a bye for now.